I say it's greater than 9. Okay? If we go get 14, probably going to concede and say that, yeah, you're right, it's greater than 9, right? Like, you probably give up and say, yeah, it's 14, 14 is 9, close to 9. Okay? What if we get 10? Are you going to fight it a little bit more and say, man, I said it was 9, like, that's pretty close to 10, right? Like, that's not that far off. That's one more. Like, you don't even take a 1-hour class. Like, what is that? Okay, so 9's closer than anything you said. Okay, what if we got that the average was like 9.2? They're just going to say, round down, right? Round down, 9.2 is 9, I'm right, okay? So what a hypothesis testing does and what our numbers and stats do is we're going to determine, like, where that breaking point is to determine if she's right or if I'm right, and, like, what number do we need to get to clearly say that which person is right, which one's right, the hypothesis or the null hypothesis. So our analyzing data does go back to the normal curve, okay? There are a couple different ways we're going to do this, but what she would want here is the mean to be 9, okay? I want it to be greater than 9. Like, what I want is something way over here to make it clear that it is something greater than 9. And, well, she really like it to be less than 9, but if it's a little bit bigger than 9, she can argue it and say, no, it's 10, that's close enough to 9. Like, that doesn't even count, okay? So what we're going to do here, what this is called, this number, we can do a z-score. This is called our critical value. And our critical, nope. Sorry, got confused there. This is called our test statistic. Okay. Our test statistic. Our test statistic kind of tells us where we land on this chart. The way we're going to analyze this is using a critical value. Okay, we saw critical values when we did confidence intervals, that little chart to the side. Those are critical values. When you saw 95% confident, right, it was like 1.64. And I think it's 1.96 on this one. So what the critical value is, if we said we want to test this at a 95% confident, we would say, okay, it's 1.64, and that may be right here, and this is called our critical value. And then if our test statistic is bigger than that, if our test statistic is in this range, then we would say I'm right, it is greater than 9. But if it was less than that, we would say she's right, it's less than 9. It's more likely to be less than 9. Does that kind of make sense? So our critical value tells us where our cutoff is. That's the spot, 9.5. If it's more than 9.5, I'm right. If it's less than 9.5, she's right, right? Okay, so you have those numbers right there. That kind of breaks it off. And then the test statistic is what you do there. So if on this one, it would be if the test statistic, well, I'll say conclusion now. Here, we'll go to conclusion. If the test stat is greater than the critical value, what they say is we are going to reject the null hypothesis. And then they say there is evidence to support the claim. They call it the claim. And then the claim is the alternate hypothesis. Okay. But if the test statistic is less than the critical value, we would, what they say, and this is what we're saying, like if we're less than, we're right here, we're saying she's right, right? So we don't want to say, we don't know for sure if she's right, we're just saying she's not wrong, which are two different things. We're saying do not reject the null hypothesis, okay? So we're not saying we for sure know that it is equal to 9. Remember, statisticians never want to back themselves in a corner. We're never going to say that it is for sure 9. We're just going to say we don't know that it's not 9. Okay, there's not enough evidence. So what they say is that what I just said, there is not enough evidence to support the claim. Okay, so the thing to remember here is that the nots go together. If you do not reject, there is not evidence. All right. The last thing I will say here is this right here, like if I want greater than, I want it on this side, right? They call that a, greater than is right here. They call that a one-tail test. Some people call it a right-tail test. I'm going to put right tail because I like right tail. Because greater than would be the right side, right? I want it to be on the right, so they call it a right-tail test. The less than would be a left-tail test. And then this would be a two-tail test because this one says it gives you two critical values and says if I land here or here, that person is wrong because we just want it to be different than that. And we'll run into that in just a second. All right, let's go look at a problem. Starts very easy. The mean SAT score in mathematics is 515. I shouldn't have. I don't know why I solved that one. I'm skipping that one because I just solved it. I shouldn't have solved it. A college professor states that this year's entering students appear to be smarter than the entering students from last year. Okay, the college registrars indicate that the mean IQ for entering students for earlier is 110.3. Suppose that we want to sample a small number of this student's years entering students and carry out a hypothesis test to see if this professor's statement can be supported. Okay, so my original is always equal. So the mean is equal to our old number, 110.3. That's my HO. He says that this year's entering students appear to be smarter than. So he would expect their IQ to be greater than. So that's what I mean by you have to just read the problem. The first one is always equal, and then you have to read the problem for the second one. Okay? If it says different than, let me see if I can get one of those real quick. This one. A coin-operated drink discharge. Let's see. She wants to carry out a hypothesis test to see if the true mean discharge differs from 9. This is the hardest one to find when it is not equal to. If it just says different, then it's going to be not equal to, okay? I guess I could take a screenshot of that real quick and just put it in the notes. By the way, I know my website's being funny, or maybe it's not updating or whatever. If you have trouble finding anything, just search me on YouTube and find my channel. Because that's going to have all the videos up there. I always get the videos up. All right, the next one. So one of the things that this does, and this is once you get the pattern of these, it goes really quick, is we're talking about mean, right? When I did on my example earlier, I did the average credit hours. This is talking about the average whatever, average IQ and the average ounces in a coffee. These are means. Every topic that you do, not only will you do the average, you will also go do a proportion, okay? But everything when you do mean or proportion works the same way. The test statistic will be a little bit different, but everything works the same way. So instead of talking about means here, we're talking about percentages. What percentage of babies weigh less than 41? Oh, the percentage of babies that weigh less than 7 pounds is 41%, okay? So when you do proportions, it's not any different. Make sure that you use P right here. So make sure do not use this one, use this one. My pound less than, well, what does it say? Oh, okay. Don't get confused on this one with the less than. The percentage of babies that weigh less than 7 pounds is 41%. Okay, so this is 41%. I don't care that it says less than 7 pounds. That has nothing to do with the 41%, right? Less than 7 pounds is just our marker. 41% is less than 7 pounds. I know when they start throwing things out like that, it gets confusing. But then it says we're testing to see if it's greater than 41%, okay? That's where you got to look for those. When we go through these, this is why it takes a long time to get started on these, as we've talked for 15 minutes and we haven't done like a big problem yet. Once you get the basis of these, it doesn't matter if you're using proportions or means, they all kind of work the same way. I'm just making sure I was doing the same order there. All right. Oh, man, that's not the easy one. Where's like the easy one? All right, I kind of want to work this on the screen. I'll see if I need to write anything. But suppose there's a claim that a certain population has a mean that is different than 9. Okay, there's my hypothesis right there. They give it to you. They give you our hypothesis. So, we just found those, but they give it to you right there. The first one's always equal. This one says different, so it's not equal to. So we go collect this large random sample from population, and we test it at the 0.10 level of significance. The 0.10 level of significance goes along with our confidence level. So if my level of significance is 10, my confidence level is 90%, okay? The 90%, remember confidence levels, that's the middle. 90%'s in the middle, so 10%'s on the outside. That makes sense? All right, so they give us our critical values here. This is a two-tail test. You have to choose if it's less than or greater than it's one tail. If it's not equal to, it's two tail. So I'm going to do negative 1.645, 1.645. Oh, I didn't do negative, did I? I did negative, it's just not typing. Okay, so this is called my rejection region. And I'll write this out in just a second. Oh man, I'm gonna have to flip it when I do the writing, but this is called my rejection region. So that's my 10% on the outside. The middle percent is a 90% confident. I'm 90% confident, so at least 5% on each tail. The test statistic, they give me that number on this problem. So when we first start, we're just doing the easy stuff right here. We don't have to do any calculations. They just kind of give it to me. Negative 2.372. Y'all see where that is on the chart right there? That negative 2.7372 is right here. So that is in the rejection region. That is far enough away from my middle that I would say it's not going to be 9. It's going to be something less different than 9. Okay? All right. So we would say that it does lie in the rejection region, and so we will reject it. Give me a second. We'll kind of write some stuff out here. Oh, no, did it? All right. So they give us the hypothesis. That's all. Two tails. So less than or greater than is one tail. Not equal than is two tail. Okay. These areas right here are called the rejection region. Our task is it does lie in the rejection region, so we should reject it. That's all you have to do on these. Like I said, it kind of starts very easy, just gives you the process of it. Okay, now let's go to like the full one. I think this is as hard as they get for this section. A company that manufactures batteries used in electric cars is reporting that their newest model of battery has a mean lifetime of 25 years. To test the company's claim, a competitor has selected 42 of these batteries at random. The mean lifetime of the sample is 24.2. Suppose the population standard deviation is 4.2. Is there enough evidence to reject the claim that the mean lifetime of the newest model is 25 years? Okay. So we have to write this out. The first one is always going to be equal. Mean is equal to 25. And we think it's different. I think it's going to be different. Mean does not equal 25. So it doesn't really say less than or greater than anywhere, right? It doesn't really use the word different. Is there enough evidence to reject the claim that the mean lifetime of the newest model is 25 years? So there is and isn't. Like there is no less than or greater than there. So just making sure before we moved on. All right, so the first thing this one does is this one does not give me the critical value on it, but it gives me what z-score to use. If I'm using a 10% level of significance, that means I've got, if I'm doing 90% in the middle, so I got 5% on each side, right? So that is why it says right here, I know y'all can't see my pencil, but it says right there, I'm not tall enough, Z.05. That's because you have 5% on each tail. And that 5% on each tail adds up to 10. So it says the area to the right tail, so Z.05. I do Z.05 in the calculator, and I get 1.64. We are doing a two-tail test. Now, I got 1.64. How many? It says 645, I guess, right? This is the thing with the two-tail, is everything is symmetric. So if the right side is 1.645, then the left side is going to be negative 1.645. So what basically we did is we found 5% to the right. Well, then 5% to the left is going to just be the negative. Does that make sense? Why didn't it look like that one's on there? Sorry, it just didn't look like it was drawing the picture. Okay, so there's my rejection region. So that's the hardest part about this, is trying to figure out which one's the left tail, which one's the right tail, which one's 2. That's probably the hardest thing in this whole section. The test statistic, you have to find that in the calculator. Okay, so they give you the formula. You don't have to memorize that formula. The formula will be on all of these. So X bar is my sample. My sample, the mean lifetime is 24.2. And then the number we're fighting about is 25. Oh, no, I did. Somebody stop me when I type wrong number. Can't hit any of the right. Oh, my goodness. Oh, wait, that was right, wasn't it? Now, my standard deviation is 4.2 divided by the square root of n. Selected 42 batteries. Square root of n. Y'all good with those numbers? Sample minus the mean that you're arguing about, divided by standard deviation square root of n. They should also be right there. That is negative 1.234. Is it really 1.234? Okay, so this one, it looks like it's not in the rejection region, right? It's in the white area. Okay, so it is not in the rejection region. So what we're going to say, it is not rejected. It doesn't lie in the rejection region. It's not rejected. There is not evidence. That is the key here on these, is to make sure. I'll leave that right there. Make sure you get the ones that say not in there. So let's write some stuff on here. But you just go back through here. I know I kind of skipped through those because the answers, I can tell you this right now, the answer is always A or D. The other ones don't match up because it's always the nots go together. What I mean by the nots go together is, let me get a highlighter here. Doesn't lie in election, is not rejected. There is not evidence. Okay, it will never be does lie and is not rejected. I can tell you right now that it's never these two. I know it's kind of cheating, but it's either it has all the knots in it or it doesn't have all the knots in it. So our Z.05, we just use the calculator, right? Just use the calculator for that. And then our other one right here, let's go ahead and, well, we got it written out right here. This is negative 1.234. So that's everything we did. We did 2 tail because it's not equal to. And then I will write this on here just in case you go back and look. This is 1.645. Then you use symmetry to use the negative, the left side, negative 1.645. Okay, this one's the t-test. We talked about the t-test when we did confidence interval. Really, it's kind of just like a z-score. It's a t-score. Let's just read the final sentence on this one instead of me reading to you. Complete the parts to perform a hypothesis test to see if there is enough evidence at the 5.05 level of significance to support that the mean number of calories professional cyclists burn during the Monaco is less than 6,800. So that's all I need really from there right now. So the first one is always going to be equal. The next one's going to be less than. And we got our answer. Okay, so 1 tail or 2 tail? 1 tail because it's less than. Okay, it'd be the left tail. So that means my test statistic should be, my cutoff value should be negative. Number of degrees of freedom. Remember, that is always n minus 1. The n right here is we sampled 21 randomly selected people. So you always do 1 less than that. We kind of talked about that. You use the t when it's a small set. So you work the numbers with 1 less to make it kind of work better. All right, so now we go to the calculator. 0.05 to the right. I think this is going to give me the wrong number, which is fine. 20 degrees of freedom. Okay, that gave me a positive, right? So if I were to just go put that on here, hopefully you start to recognize this. What's wrong with that? What's wrong with this whole scenario? How many tails is it? What tails should it be, the left or the right? It should be the left because it's less than, okay? So all I have to do is go change this to a negative. And it is going to be the same thing. Okay? technically you could do, on here you could do 0.95, but that just seems like too much work. I think I would just, oh man. That would give you the negative, because 5% to the left would be 95% to the right, if that makes sense. But I always just do the positive and negative, okay? Because it's always going to work that way. Now your test statistic. Test statistic would be, we got it right there, my X bar. So their sample of 21 people had 6583 minus 6,800 divided by the standard deviation, which was 364, divided by the square root of n, which was 21. Okay, so that is negative 2 point. I'm just going to click solve so I don't have to type it in there. Okay, so it kind of works the same exact way. The formula is just a little bit different. All right, I was trying to get all of this on one shot here. This hypothesis testing making sense? All right, we got one more to do, I guess. We got to do the proportion. But this is the majority of what we do for the rest of the semester is this thought process right here. This was negative 2.732. For this, T 0.05 actually gives you this, which is 1.725. So use symmetry to find this. Anything else? The less than would be less than right there. This one's always equal. Anything else I can add that you'd like on there? Oh, degrees of freedom is n minus 1. So this is 21 minus 1. Can't see that, I guess. Less than, oh, let's do this real quick. Let's, did I do these backwards? No. It does lie in the rejection region, so it is rejected, and there is evidence to support. Okay, I was thinking there for a second that the last one was do not reject. I did that yesterday in college algebra. I completely messed up something like really easy. Just completely switched it around. I didn't realize it for like 2 problems. And then all of them were like, yeah, you did. And I'm like, why didn't you tell me? Okay. Last problem is one with a proportion. Everything basically works the same way. You see the test statistic is a little bit different. The test statistic is harder. I really wish they had a button for the test statistic, but they don't. So let's look at this one real quick, and then we'll probably be done. At a nearby college, there is a school-sponsored website that matches people looking for roommates. According to the school's report, 38% of the students will find a match with their first time using the site. A writer for the school newspaper tests the claim by choosing a random sample of 165 students who visited the site for a roommate. Of the students surveyed, 46 of them found a match. Complete the parts below to test. Is there enough evidence at the 0.05 level of statistics to reject the claim that the proportion of all students who find their match at the site is 38%? So is 38% is going to use the equal sign. So I do P equals 0.38. And P does not equal 0.38. Y'all good with that part? All right, the next part is for part B. We have not done this yet. But what this does is test to make sure that you have enough numbers basically to run the test. Okay, if I only ask 10 people, then I can't really run the test. So this is you do n times p. So I'm going to do let's do n first. N is 165. P is 0.38. Okay, so that's 62.7. Then we do it the other way. So if 38 people said yes, or 38% found a match, 165 times, you can just do that in your head if you want to. But if 38 found a match, that means 62 did not. So you find out how many said yes, how many said no, and you multiply them, 102.3. All right. As long as those numbers are both bigger than 10, you can see it right there in the directions. As long as those numbers are greater than or equal to 10, you're good and you can do the test. Every time it's greater than 10, but you still got to fill out the blanks. Okay, so it's never not going to be greater than 10. Next thing, it says use Z.025. Well, this is a two-tailed test, right? Because my level of significance is 0.05, so I use 0.025. So I do Z of 0.025. I press equal. So that would be, I'm clicking solve, so I don't have to type those all in. That would be 1.96, but it's a two-tail, so I use negative 1.96. Does everybody understand that when it's 5% and it's two-tail, I got to cut it in half. So I do 2.5% on each side. But if it was 5% in one tail, then I would just do 5% to the right tail or 5% to the left tail. Does that make sense? So that is why, like, because in my head, I'm always like, why doesn't everybody just say different? Because different could be greater than or less than. But that limits the amount, because if I did 5%, I'd have to do 2.5% on each side. Whereas if I just did greater, then I could do the whole 5% on one side. Test statistics. So this is like the hardest one to do in the calculator. I like using the Alex calculator just because I can see it. So that p hat right there, you do the sample. 38 divided by, not 38, 46 divided by the 165. That's from our sample that we did. We sampled 165, 46 said yes. So minus the 0.38. Then you do the square root. I'm going to go ahead and click divided by again. 0.38 times 1 minus 0.38. Again, you could just do 0.38 times 0.62 if you can do that in your head. And then my n was 165. And that should give me that number, that negative 2.678. So I would always try to do the Alex calculator just to make sure that you can like see it all right there, and hit the division symbol first and then try to do it, because then you don't have to highlight. So that is, you can see that way over here on the left-hand side, the negative 2.678. That is in the rejection region. So we would reject the null hypothesis, and there is evidence to support the claim. Okay. So just to write a couple things real quick. That is all that this is. Once you get the hang of this a little bit, it does go pretty easy. So here NP is 165. My goodness, it won't let me too like close to the top or whatever. And 165 times 0.38, and then times 1 minus p. You can do it in the calculator, but it's 155 divided by 0.62. And then this right here equals the negative 2.678. This right here, when you do it, I think y'all got the hang of that. Y'all are acting like you got the hang of it at least. Y'all did good on your midterm, so I'm just trusting y'all on this part. 1.96. So then use symmetry. You get the negative 1.96. And then it lies in the rejection region. It is rejected. There is evidence to reject the claim. I guess we could put not equal to there. All right, so that does finish up hypothesis testing. What we will do on the next time is kind of an extenuation of hypothesis testing. It's actually a different way to do it.